Good day, learners. Welcome to today's session. In this session, we'll be looking at functions and equations. So, if you can check what we're given here on question 5. Question 5, we have g of x and we have f of x, right? So, g of x, if you can check g of x, you have g of x equals to negative 2x squared plus 4x plus 16. So g of x, when you see g of x here, you must be able to tell what kind of a function is this. So in this case, since we have x squared here, it gives you a clue that this has to be a parabolic function, right? And then f of x, you see you have 12 divided by x plus p and then plus q. Just because you are dividing by x here, it must give you a clue that we're dealing with a hyperbolic function here. So the first question, they tell us what? They tell us to show that g can be represented by the equation uh, minus 2 and then brackets x minus 1 squared plus 16 plus 18, sorry. So what you need to do here, you need to copy this equation here, and then after copying the equation, you need to complete the square to get it into this form here. Into this form here, you need to complete the square from here to this form, right? So let's first write this equation that we're given. Sorry, it's g of x. The one that we're given is negative 2x squared plus 4x plus 16, right? And then the first thing we need to do here, we need to take the common factor. What is the common factor here? It's negative 2. You can see negative 2 it's the common factor here. So negative 2 here will have x squared and then minus 2x minus 8. Okay, and then what do we do? What's the next thing we need to do? The next thing that we need to do here is to complete the square. How do we complete the square? We complete the square by first looking at the coefficient of x. So what is the coefficient of x here? The coefficient of x is negative 2, right? So what we need to do, we need to add the coefficient, the half of the coefficient of x. Okay. So negative 2 divided by 2. Okay. We square it. And then we minus negative 2 divide by 2. We square it as well. And then we have plus, we have negative 18. The negative 8. Must not forget negative 8 so that I don't have enough space there. So what we need to do, let me write it properly here so that you can all see, because I didn't have enough space there. So I'll just copy everything. Okay. So negative 2 divided by 2, we know is negative 1. And then when you square it, you get 1. And then same as this one, but you are minusing this, right? You minus 1. And then you have what? Negative 8. So I just copied everything and I only simplified what's in the brackets first, right? Because both you must deal with what's inside the brackets first. So everything is still the same here. I hope you can follow. So we have negative 2. What we need to do now is to simplify. What do we know? We know that this x squared minus 2x plus 1 will equal to x minus 1, x minus 1 squared. Okay, x minus 1 squared. So negative 1 minus 8 will give us negative 9. So we have negative 9 here. So what we can do next is to multiply this. We multiply these sums inside the brackets here. We have negative 2 x minus 1 squared, and then negative 2 times negative 9, it's plus 18, right? So we can see it's the same as this one. So our g of x will be equal to this. So we have showed that this g of x here can be represented as what? As the one here, right? By completing the square. Okay, I hope you got that right. The next thing, okay, let's see question 5.2. So question 5.2, they say hence or otherwise determine the coordinates of Q. So when they say hence, normally they mean that this question is derived from question the previous question, right? So they want the coordinates of point Q. But remember now we proved that it can be written as this, right? And in this form, we can able to check the turning point. So this is the turning point form, right, of g of x. So if we know the turning point of g of x, right, we can know the coordinates of q, because q here is the turning point, right? So what we need to do now, we need to write the coordinates of the turning point. So we can write here uh, turning point or TP, right? The coordinates will be, since you see here we have x minus 1, we'll have 1. And then here we have what? We have 18. So it's 1 is to 18, right? So it means the coordinates of Q, point Q. So it will be Q. The coordinates will be 1 is to 18. Right? So these are the coordinates of point Q, right? And then 5.3, they ask us to calculate the coordinates of point D. So if we can check point D is the x-intercept of of g of x. So we need to check x-intercept of g of x, because this is where the graph cuts on the x-axis, right? So 5.3, g of x, we know g of x, we can even write it in this form, the original form. Okay, so we just need to check the x-intercept. Then y will equal to 0, right? So y and g of x is the same. So y, if it's equals to 0, g of x will equals to 0. So we'll have negative 2x squared plus 4x. Sorry, this is plus 16 here. Plus 16 will equal to 0, right? We can just divide by 2, negative 2 everywhere. We'll have 2 squared minus 2x x, and then minus what? 8. All will equal to 0. So what we need to do now is to find the um, the factors for x squared and 8, for which we add or minus, we get negative 2, right? So we'll have um, the factors for x will be x and x, we know, okay? And then the factors of 8, we can have what? We can have negative 4, and we can have positive 2, right? All will equal to 0. So we have x will equal to 4, or x will equal to negative 2, right? So these are the coordinates of x. So they wanted what? They wanted point D. So you can see the negative 1. So the coordinates of D, you can see here, it will be negative 2 is to what? Is to 0. Remember, this is the x intercept, right? Y will always equal to 0 at the x intercept. Okay, and then moving forward, we look at 5.4. So 5.4, they want us to determine the equation of the asymptote of what? Of f, and state the values of p and q. So how can we find this equation of the asymptotes, right? We can see that this asymptote here, it shares the x-intercept with this graph of g here. So it shares the value here. So we know that this one, x will equal to what? Negative 2. And then here we can see here it shares the value here with this graph g, the turning point here, right? We can see here our value of y. We know the value of y from the turning point here is what? It's it's 18, right? It's 18. So we need to use the information that we know. So okay, say 5.4. So 5.4, okay, they want us to know to check the asymptotes, okay, for p and q. So we can see the p1 here, these are the x asymptote, and then the q1 are the y asymptote. So the one that's affecting the x asymptote p. So we have noted that here it's x will equal to what? Will equals to negative 2, right? So we have to note that x will equal to what? At the asymptote will equal to what? Negative 2, right? But we are not looking for x, right? We are looking for what? We are looking for p. And then p will equal to what? Will equal to 2, right? So it's x plus 2 here. So p will equal to 2. And then our y value, remember I said y will equal to what? 18. And then our q value, this one won't change. It will be y q will equal to what? To 18, right? We have done with our asymptote, right? So this is the equation for our asymptote. So this p is our asymptote 2, and then q is our asymptote 18, right? So we are done with our asymptotes. And moving forward, 5.5, they asked us to determine for which values of x the graph of g will decrease, right? So we need to determine the values of x for which the graph G will decrease, right? So if we can check here, the graph, remember here, these are your negative values for x, right? So remember, you always move from negative to positive, always, right? So here it's moving from negative, right, to positive, right? Right? Like this. So moving in this way, what's happening to our to our graph of G? We can see it's increasing here, it's increasing here, it's increasing here, it's increasing here, up until it reaches this turning point, right? And then from here it starts to decrease. The values of G, they start to decrease. So the values of x for which G will increase. So we can see here from the turning point here, we know the turning point here, x is 1 here, right? So any values that greater than 1, right? We can see that the graph will it starts to decrease. So how do we note it down here? Okay, 5 point, okay, it's 5.5. So we can see from here, from the turning point here, because we know the coordinates here, it's 1 is to 18. Let me note this down. 1 is to 18, right? So from 1 here, so 1 greater than, x greater than 1, right? So x, where x greater than 1, this graph is it starts to decrease. So your answer is when x is greater than 1, right? It starts to decrease, right? And then moving forward, they want us to write down the range of G, right? So remember, the range refers to the Y values, right? So if we can see the Y values, the maximum Y value of G is 18 here. So it has to be from 18. So the values or the range of G, you can say that y is the element of what? This will include what? 18 to what? To infinity. To positive infinity or negative infinity. Remember, this graph is going down, right? So it has to be negative infinity, right? So this is negative infinity, right? So don't forget that the graph, this is the maximum 18 here. Why? It's going down, right? So it's from 18 to what? Negative infinity. So the 18 has to be included because it's in the turning point here and to infinity, right? So moving forward, they ask us to calculate or to write down the domain of f. So what will be the domain of f? What is the domain? The domain is, it refers to the x values. So we can see from here, right? We have the asymptotes here. So, and also here we have the asymptote here. The asymptote of what? Of x equals to what? Equals to -2. Yeah, so it's -2. Okay, just needed to confirm that. What was the asymptote? -2. Yes, it's -2. So we can say that the domain, okay, 5.7. So the domain will be what? X will be the element of what? Of negative infinity to what? To positive infinity, right? So from negative infinity, yeah, to positive infinity, this will be the range of will be the domain of x. But remember, there's an asymptote here on x. So it means that negative 2 won't be included, right? The x equals to negative 2 won't be included. So you need to note that but x is not equal to what? Negative 2. So it must not equal to negative 2. Why? Because there is an asymptote where here at x equals to negative 2. Okay. We have come to the end of today's session. Please don't forget to like and subscribe, and I'll see you on the next one very soon. Thank you.